So guys, this is a brand new course on Matplotlib, and basically Matplotlib is a Python module which is used for data visualization. If you want to go into the data science field or machine learning field, it's necessary to learn Matplotlib so that when you are working with a large amount of data, in that case it is really helpful to showcase the data in a beautiful graph like picture or like any kind of plots. Okay, so because we have some values on the x-axis, some values on the y-axis, and in case if you are plotting any three-dimensional plot, then in that case we have the z-axis also, so you can set some data for z-axis as well, right? So in this course we will learn about basic line plot, then some formattings, then also we will see how to change the styles, and then we will see for bar plots, then all kind of plots, basically scatter, histograms and all. Then we will lastly see that how to plot a three-dimensional graph. Okay, so join in this course. Let's learn Matplotlib together. Okay. So guys, I hope you already watched our intro video. So it's time to install Matplotlib and do a basic graph. Okay, so you can clearly see these are kind of graphs you can plot using Matplotlib. I'll put that link under this video. Okay, and you can check this out. You can plot this kind of graphs using Matplotlib. And if you click on this tutorial page, you can come through this page and you can see this is PyPlot tutorial. Okay, so first of all we will see how to draw this pie plot. Okay, before that obviously we have to install Matplotlib in our device. So to install Matplotlib in our device, you have to just run pip install Matplotlib. So obviously you have pip in your device. You should have pip in your device. Okay, so while installing Python from the official website, you must check mark this pip option. It will you will get when you install the Python on your device. Okay, otherwise you can also run this line of code, python-m pip install-u pip. Okay, this will actually install and upgrade the pip, and then we can just run this code. Okay, let's copy this thing and let's open PowerShell, or you can use CMD, and if you are using Linux or Mac, you can just use terminal. Okay, let's paste that particular code. Yeah, now let's enter. You can see it's loading and it's downloading Matplotlib on our device, and then it will install automatically. Okay, well, yeah, you can see downloaded the Matplotlib. Now it's installing the Matplotlib. Yeah, now you can see it's successfully installed on our device, and it's saying that we have to upgrade our pip. Okay, so let's do that. Okay, because maybe I'm using a older version of pip, so that's why it's saying that we have to upgrade our pip. So let's paste that code and let's run this. So it is basically upgrading the pip, and then you can open any kind of editor. Okay, like VS Code, PyCharm, Sublime Text, anything. You can open anything, but for now, for this tutorial purpose, I'll use Jupyter Notebook. If you don't know Jupyter Notebook, that's fine. We will make a Jupyter Notebook tutorial soon. Okay, and yeah, it's basically very easy. It's normally like Visual Code or PyCharm, but there is a special thing that is in Visual Code or any other editor, you have to run the total code at once. Okay, but in Jupyter Notebook, you can run a particular cell at a time. You don't need to run whole code at a time. Okay, so it is very easy for you to understand that particular line of code. Okay, so because it is running only that particular line of code, it is not running full the whole overall codes. Okay, so yeah, that's why we are going to use this Jupyter Notebook. So basically, to open Jupyter Notebook, you just need to go into that particular folder and shift plus right click and then open PowerShell Windows here, and then there you can just write Jupyter Notebook. Okay, before that you should install Jupyter Notebook on your device. Okay, that's the case. You have to obviously install the Jupyter Notebook on your device. Okay, that's quite easy. You can just go into Anaconda. Let me just show you that thing quickly. Okay, you can just go into this anaconda.com, or you can just write Anaconda download for Windows or Mac or Linux, whatever you are using for Windows. Yeah, just go into this installing on Windows. Okay, that's documentation. We don't want that. We just wanna find out the download link. So let's go into the documentation. We will obviously get the link from there as well. Yeah, you can see, download the Anaconda installer, and just click on that, just verify the downloader, and then you can install the Anaconda, and it will come with Jupyter Notebook. So you don't need to install Jupyter Notebook manually, then it will come with Jupyter Notebook, and you can obviously use the Jupyter Notebook. Okay, and after opening the Jupyter Notebook, you will get to see this kind of screens, and then click on this new and then Python 3. Okay, it will create a new project, and I name it Matplotlib. That's fine. So now we have to check whether the Matplotlib installed properly or not. Okay, so for that you can just write from Matplotlib import pyplot. Okay, but basically in technical terms we don't use pyplot every time. Okay, we make it shorter, that is plt. Okay, so import pyplot as plt. That's it. Now let's run it. Now you can see it didn't throw any kind of error. That means Matplotlib is successfully installed on my device. Okay, but if it shows any kind of error, that means Matplotlib is not installed on your device. Okay, you have to install it then again. Okay, so yeah, you can see I already ran through this line of code only. We didn't run the whole code. So obviously we have only one single line. Let me show you that thing. Okay, so yeah, let's do one thing. Print hi. Okay, and here we will write print hello. If I run it, well, it's being shorter, lowercase. Okay, fine. So if I run it, you can see it only print hello. It is not printing hi. That is because we ran only this cell. So this is the basically special thing about Jupyter Notebook. You can obviously use that. In this tutorial, we will use that thing. So it's better to understand these basic things in Jupyter Notebook. Okay. Anyways, so let's plot a basic, graph. Okay, so I'm going to basically write the x-axis data and y-axis data manually for this video only. Later on we will see how to use the external data source like CSV files, Access files and all. Okay, yeah, so for this video only I'm going to write the data manually. Okay, so I'll just write and I'll come back after writing this all data. Okay,
2000 years later.
So I wrote two lines of code. That is, first one is for x-axis, the values are for x-axis, and then the second line is for y-axis. Okay, so yeah, you can say these are the age and salary kind of graphs. Okay, so in 25 age the average salary of the person gets is around 30,000. Then at 26 they get 35,000. Obviously this is not the correct data. I just wrote it for this demo video. Okay, and then if you want to plot this graph using these values, you just need to write PLT. That is because we short this pyplot as PLT. That's why we're writing PLT instead of pyplot. Okay, so PLT dot plot, and then we have x values, x-axis values, and then we have y-axis values. Okay, that's it. But now this will not show you the graph actually. If you want to see the graph, you just need to write over here plt.show. Okay, now it will show the graph. So let's run this cell. Yeah, now you can see this is the graph. Obviously this will be a straight line. That's because these values are increasing with I think 5,000. Yeah, it's increasing with a constant value, that is 5,000. Let's make it something different, like it is 33,000, and then assume this one is 48,000, then this is 51,000. Okay, let's run it. Now you can see this is a curvy graph right now, and you can see these are the ages which you created for x-axis, 25 to 35. So this is the 25 position and this is the 35 position, and it is showing some in middle values. Okay, and these are the salaries, okay, which we created for the y-axis. It starts with 30,000, you can clearly see over here, and then it goes till 80,000. That's fine. And yeah, that's it. So that's it for this video. This is how you create a simple graph. Okay, this is the starting of this video. Later on we will see how to use the external data files and how to create complex graphs. Okay. So guys, we already saw how to plot a basic graph, but if you send this graph to someone else, they'll obviously not understand like this plot is graphed of what purpose. There is no labels, no titles, nothing else. There are some values. They'll obviously don't know what these values are. So yeah, for that case you can just use a title and labels. Okay, So a title for the overall graph, and for x-axis there should be a label, for y-axis there should be a label, something like that. Okay, so I'll just copy this line of code from here and paste it over here. If you are creating another Python file, if you're using like any other code editors like Sublime Text, VS Code, or PyCharm, okay, so if you're creating any other Python file, you obviously need to write this from Matplotlib import pyplot as plt again, okay, because without that the Matplotlib will not be used in that particular Python file. Okay, so you have to write that again, but since we are using Jupyter Notebook, we don't need to write that again. Okay, so yeah, these are the x-axis values and these are the y-axis values, and now this is creating a plot of x and y-axis. Then we are just showing that particular plot. Okay, but before showing that particular plot, we actually want to add a title and add two labels for x-axis and y-axis. Okay, so yeah, after creating this plot, we are going to just write over here plt.title. Okay, and then we can just write over here salaries based on age. Okay, that's it. You can write anything over here, and then we need some labels for x-axis and y-axis. So the x-axis are like these are the ages, okay, and the y-axis are like average salaries, right? So we just need to write over here plt dot x label, and then we are going to just write over here ages, okay, and that's it. Now for y label, sorry, yep, we are going to write over here average salaries. Okay, that's it. So yeah, let's run this code. So now you can see this title is now added over here. Okay, it's opening that image. Anyways, so yeah, you can see, let me just zoom it a bit. Yeah, now you can see we have this title over here, salaries based on ages, and for x-axis we have this label ages, and for y-axis we have this label average salaries. Okay, so yeah, now they'll understand, like if you're sending this graph to someone else, obviously they'll understand like for which this graph is made actually, because now we have labels and title for this particular graph. Okay, so in this way you can use these title and labels. Since we already saw that how to add title and labels, now you may have doubt, like if you have multiple conditions, like we have these ages, right, and we have this average salary. So assume these are the average salaries for all developers, okay, like Java, Kotlin, all developers, and we also want to plot a graph of Python developers with this particular graph. Okay, so let's just copy these lines of codes from here and paste it over here, and you can see this is the ages. Okay, so if you have similar kind of ages for Python average salaries also, then you don't need to write it again. Okay, if you have different ages, then obviously you can write that again. Okay, so yeah, it's diff x, so I'll just write over here all ages and x for the x-axis. Okay, so these are the ages for all developers. Okay, and these are the like, yeah, these are the all developer salaries, and now we are going to write one more a list of Python developer salaries. So I already opened that in my second screen, and I'll just copy that from here. Okay, I'll copy that thing, and after plotting the first graph, I'll just paste that particular line. Okay, so this is the Python developers average salaries. So this is all assumptions, so these are not the true values. Okay, so don't go on that. And yeah, now we again need to create another plot for these particular values, right? So we are going to just write over here plt.plot, and in the parentheses, since we have the same x values, so we don't need to send any other list. Okay, so I'll just copy this list from here. Okay, I need to paste it over here as well. Yeah, now I'll paste it over here, and then we just need to write over here Python div y. Okay, that's it. So yeah, let's see what's going on over here. So these are the ages. okay, of the developers, and these are the basic salary, or you can say average salaries of all the developers. And then we plotted a graph using that age and that average salary, okay, average developer salary, and it will show this kind of graph, okay. And then we added one more conditions, that is we added Python developer average salaries, okay. So these are the Python developer average salaries, and we again plotted a graph with the same age values and a new Python developer salary values, okay. Then we have this title, that is this thing, salaries based on ages, and then we have the x-axis level, that is ages, and then y-axis level, that is average salaries, okay. So now if I run it, you can see we have two lines over here. So the blue one is, I think, the all developer salaries, and the orange one, or you can say yellow one, has this Python developer salaries, okay. But it is difficult to understand which one is for whose, right? So you can't really understand which one is for all developers and which one is for only Python developers, right? So in that case, we also need to use a legend, because over the top left corner we want to showcase one thing, that is like for Python developers the lines are in orange, and for all developers the lines are in blue, right? So we will, after writing these y levels, we are going to just write over there plt.legend and legend, and inside the parentheses we have to pass a list of the values, okay. So the first plot is for all developers, right? So I'll just write over here all devs, okay, and the second one is for Python devs only, right? So Python devs, okay, that's it. So now if I run it, now you can see the blue one is for all devs and the orange one is for Python devs, okay. So you can use the legend using this method, as well as there is one more way, which is more simplified method, that is here you have to note which plot is the first one, then which plot is the second one. If you have multiple plots, then it is really difficult to check all the plots serially, right? So in that case, I'll just mute or you can say comment this out, and then while creating this plot, like this is the first plot for all the developers, right? So while creating this plot, we can just use one more thing, that is label, okay. Label, okay, and that will be equals to, like, it is for all developers, right? So all devs, and then we can just create one more label for the second plot, and that will be for Python devs, okay, that's it. Now if I run it, well, it is not showing this thing, that is because we didn't write the legend, okay. So we have to write this thing, so pld.legend, and now we can just write only a blank parenthesis. We don't need to write the labels manually, okay. It's because we already write those labels while creating the plots. So this is really a easy method. So let's run this cell. Now you can see we have these things over here, right? So in this way you can use the labels for different conditions, and in this way you can basically use this legend method, okay. So guys, now we are going to see about format strings, okay. So let's go into the documentation. You can just I'll put that link under this video, but still if I forget that thing, you can just go into Google and just search for Matplotlib format string, and then click on the first link available there, okay. And then just go down a bit, and then now you can see we have this format strings, okay. So basically assume we have these things, right? We already create a graph of all developers and Python developers average salary, okay. We actually assumed that salary, that is not the actual salary you will get if you are Python developer, okay. Anyway, so you can clearly see that for Python developer the color is orange and the all developer color is blue. But normally in Python logo you can clearly see over here the main color is actually blue, right? And assume for all developers we want to use some different colors, and assume for all developers we want to use some different line structure. For example, this is a solid line structure, right? But you can also use dashed line structure, double dashed, and so on, right? So in that case we are going to use format strings. Okay, so yeah, let's see. You can see we have markers, then we have line styles, okay, which we are talking about, like a solid line, dash dot line, dotted lines and all. Okay, and then we have some colors. Actually this is some predefined colors like blue, green, red, cyan, magenta and all. Okay, but you can also use hex code. Okay, you can also use the colored hex code, so that you will get a lot of choices. Okay, because there are billions of colored hex codes. Anyways, so let's do that actually. So I'll just copy this section. Yep, paste it over here. So basically these are all the ages for x-axis. Then we have all developer average salary for y-axis. Then we plot that particular graph, and then we have Python developer average salaries. Then we plot the graph for the Python developer salaries. Then we actually label those things. That is because we wanna show the color and all over the top left corner. So yeah, let's do that. Let's change the color of Python. So this is the Python one, and here assume we are going to change the color actually. So before the label and after writing the x-axis and y-axis values, like over here all ages x is the values for x-axis, then Python dev y is the values for y-axis. Then we are going to write assume we wanna make it blue, right? So the code of blue is B. Okay, so we are going to just put a single inverted comma and then B. That's it. That it will change the color of the Python developer. But for the first one, it's also in blue color, right? So all developer color is also blue. We want to change that as well. So let's put a comma, and yeah, inside this comma we are going to just write over here. Assume we want to change it to something red or aim. Okay, red. Let's choose the red one, and then assume we are going to use some line styles. So yeah, let's choose this one, dash dot lines. Okay, so for that we are going to just write this hyphen and full stop. Okay, so let's copy and paste it over here. Fine. So if I run it now, you can see all developer color is now red, and the line structure is actually dash dot. Okay, and for Python developer it's blue, and it is solid because that's by default. But if you just write over here, where is that? Yeah, if you just write over here double dash, it will change it to double dash. Okay, so let's run it. Yeah, now you can see it's also in double dash. Now you can see the Python developer is now changed with double dash, and all developers are in dash dot. Okay, but it's kind of complex. But if you if you're doing on a project and you can see this kind of things, yeah, you can clearly understand this is actually format string. But there is another way to write these things. Like if you are writing this code on your own, it will be really difficult to understand later on when you see that code again. Okay, so in that case you can more specify these things, like color is blue, the line style is dash dash, then the marker is this thing and all, right? So to do these things you can just write over here, let's remove this thing, and yeah, color is equals to, and then you can just write the color, that is we chose actually red, so it's R, and then put a comma, and then you can just write over here line style is equals to, and then you just paste that particular line style, that is this thing, dash dot. Okay, and yeah, let's run this code. Okay, there is a syntax error. Well, yeah, after line style we forgot to put a comma, so yeah, let's put that comma and let's run it. Yeah, now you can see it's also showing the similar thing. Okay, so you can now more specify that thing. R is the color, dash dot is the line style. Let's do one more thing. Let's remove. Okay, let's choose only color for Python developer. Color is actually B. Okay, let's run it. Yeah, now you can see this is a solid one. And now let's use the marker over here. Okay, I'll just write over here marker, and that will be equals to, you can clearly see in the documentation we have different markers. For example, for circle marker we have O, right? So just copy this O from here and paste it over here. Fine, so let's run it. Now you can see we have this circle marker, right? And now if you are If you want to make it point marker, you can just change it with point, you know. Yeah, now you can see we have this small circle marker that is actually basically point. Yeah, and then we have different kind of marker you can clearly see over here, and then we have yeah, now let's see how to use colored hex code, because you can clearly see we have a very limitation colors over here: B, G, R, C, M, Y, K and W. Okay, but in case if you are going to use some different colors, so in that case you can just use the colored hex code. Okay, I'll suggest you use this plugin ColorZilla. Oh yeah, this is the plugin extension actually, ColorZilla for Chrome or any browser. If you are using any browser, I think in every browser this is available. Okay, just install or download and install this thing on your device, on your Chrome browser, and then I'll just go into the Adobe Color. Okay, and there I'll just choose a color. Okay, yep, and from here I'll just click on it, and I'm going to just choose assume violet color. Okay, so let's click on it. Yeah, now it's, you can see it copied that particular color hex code, right? And now for, you know, Python developer, I'm going to just write that particular color code. Okay, so let's paste this color code. You can see this is the color code for that particular color which I choose, that is 821BCC. Okay, that's it. So let's run this cell. Yeah, now you can see the color is changed to violet. So let's choose some another colors, and let me show you that thing. Let's choose this yellowish color and paste it over here. Okay, let's run this thing. Yeah, now you can see now Python is now in yellow color. Okay, in this way you can use any kind of hex codes, so that you will get a lot of options, you know. And then we have what else? Yeah, so you can clearly see the Python and all developer is merging over here and it's going over here. So it's really difficult to understand these two separate lines because both are in same width. So in case you want to change the width of the line, you can just go into the documentation and let's go up. And yeah, now you can see we have this line width. Okay, so let's use that thing. So for Python, this one, yeah, after assume marker, let's remove this marker. Okay, and here I'll just use line width. That's it, line width. By default it's 1, so the width is actually 1. Let's choose something you know, 3 or something like that. Yeah, now let's run it. So yeah, now you can see the Python developer one has now more width, right? Because we choose 3 over here. Let's choose 10, it will get more width. Okay, yeah, you know, can see, yeah, in this way you can change the width of the particular line. Let's change it to assume 2. Perfect. And then we have yeah, so you can see it's really difficult to understand at what point these two lines are actually crossing, because you can't really see that particular line, right? So for that you can use the grid system. So after this legend, before the plot shows, okay, you can just add one more line, that is plt.grid, and inside the parentheses you can just pass true. Okay, that's it. Now let's run it, and now you can see we have these grids, and now you can clearly understand at what point it can actually crossing that particular value. For example, you can see this point, it's crossing the, both are like merging, right? So that means the value of x-axis is 27, because this is the half of this 26 and 28, and the value of y-axis is 40,000. Okay, so at 40,000 both have the same value, like at 26 age. So you can clearly see that at 27, okay, this is the third value, and the value is 40,000 over here for all developer salary, and for Python developer salary it's also 40,000. That means both lines are merging. So yeah, in this way you can clearly see every particular value where they are merging, or where they are actually starting increasing the values or decreasing the values or whatever. Okay, so this is all about this video. Okay, so guys, now let's talk about styles in, you know, for plotting some graphs. Okay, so you can see this is the basic style while when you plot the graph without any kind of customization. Okay, so this is the default styling of you know, Matplotlib. So I'll just copy the overall thing from here and paste it over here. and let's see how to run this tiles. Okay, before that I'll just add one more cell above this cell. Okay, so I'll just show you how many styles available in Matplotlib. Okay, so print plt.style dot available. Okay, now if I run it, you can see these are the styles which is already available for Matplotlib. This Seaborn Bright, Seaborn Colorblind, Seaborn Dark, these are really good. And then we have, let's see, 538. Yeah, these also are really good style. Okay, so let's use these styles, right? So after writing that import one like this one from Matplotlib import pyplot, and then we will just use as customization styles. Okay, so for example, we are going to use this Seaborn. Let's use poster. Okay, Seaborn poster. Okay, so plt dot style dot use, then inside the parenthesis, because this is a method, you have to write a parenthesis and then put a quotation, and then you can just write Seaborn poster. Okay, I'll just copy it from here and paste it over here, and let's run it and see. So yeah, now you can see this is that particular style, but we are also using some extended customizations. That is because we change the color, line style, label and all. So let's remove these things as well. Okay, so let's remove this color and line styles from there and over here as well. And oops, yeah, perfect. And let's remove this grid as well. Okay, let's run this cell and see. Yeah, now you can see this is the default style of this Seaborn poster, and I already told you that 538 is also a really good style. So let's copy that thing and paste it over here, and let's run this cell. Yeah, now you can see this is the 538 style. Okay, so you can clearly see that 538 style is already using grid by default. Then it colors is also really great, and the overall fonts and size is also really great, right? So in this way you can change the style. In case if you are interested in reading the documentation, you can also go into this link, just search for Matplotlib styles or style, whatever that is, and then you will see this thing. Okay, so you can clearly see, just write print style dot available, which you already wrote, to get to see all the styles available there, and then you can just use these things. Okay, and there is one more thing. Let me just show you that. Yeah, so well, there was a comic XKCD. Okay, so the graph of XKCD is like kind of cartoonish. Okay, like kind of like animated graph. You can also use that thing. That's not in that plot style, so you can't use this plt.style. You can just write plt.xkcd. Okay, that's it. And now let's run this cell. Now you can see this is kind of a curvy, cartoonish graph. Okay, so in this way you can change between different styles which you like. You can just use those styles. Okay. So guys, this is a really quick video on how to, you can see we have this plot over here, right? But in case if you want to save this plot on your device as a PNG file, JPG file or a PDF, you can also do that without installing any other module or any other library, right? So yeah, I'll just copy this code from here and I'll paste it over here. Okay, so before showing this plot inside this Jupyter notebook or inside the code editor which you are using, we can just write one more line over here, that is plt.save fig. Okay, save fig, and then inside the parenthesis you can just write any file name with the particular extension. For example, if you wanna save it as PNG, you can just write file name.png. Similarly, file name.pdf and whatever you want. Okay, so that's totally in your choice. And for example, I'll just choose this is xkcd style, right? So I'll just write over here xk xkcd.png. Okay, so let's go into my directory. You can see we only have this single matplotlib Python file. Okay, let's go into the folder as well. Yeah, now you can see we have only this thing, only the Python file, nothing else, right? So if I run this cell, yeah, now you can see it shows this plot over here. That is because of we wrote plt.show. That's why it is showing over here. And if you go into my directory, now you can see we have this png file skcd. Okay, let's go to the directory. Yeah, you can see we have this png file over here. Let's click on that. Yeah, now you can see it opened that particular plot as an image. For like more clarification, you can just double click on this image. Yeah, now you can see this opened as an image, right? So this overall plot is now saved as an image. Similarly, you can just write .pdf and whatever extension you want basically. Okay, so in this way you can save the plot on your local device. So guys, now it's time to plot a bar graph. Till now we are just plotting a line graph. Okay, so if you go into the documentation, you can clearly see this is the documentation for a bar graph. So to plot bar graph, you have to just write matplotlib .pyplot.bar. Okay, but till now we are just using plt.plot, but now we are going to use plt.bar. Okay, so yeah, I'll just copy this thing from here and paste it over here, and let's see. Okay, the style is actually xkcd. Okay, let's do one more thing. Let's start from the beginning. So we also need to use this import from matplotlib import from matplotlib import pyplot as plt, right? So yeah, after writing that, we are just styling that thing. For now, yeah, we are using xkcd. So let's use something different, So plt dot style dot use, and inside the parentheses, okay, it's already there. So here we are just going to write this one 538. Okay, and paste it over here. Perfect. And then we have all the ages between 25 and 35. Then we have the average salaries of the developers, and then we plot the graph and we label that all developers. Then we have the data of Python developers average salary. Then we plot the graph for Python developer as well. Then we wrote some title, X level, Y level, and then we put a legend. And okay, we don't want to save that as an image, so I'll just remove that line and let's run this code. Yeah, so you can see this is the graph, plot graph, right? And now we're just going to change the plot with bar. Okay, and this one should be also bar. And now if I run it, you can see now this is a bar graph, right? But there is one problem. Like all developers, like first of all, you can clearly see that we plotted the all developer graph first, right? So it plotted a bar graph of the all developers. Then it plotted a bar graph of Python developer salary. And since Python developer salary is higher than the all developer salary, so that's why Python developer salary overlap the all developer salary. Okay, so let's do one thing. Let's just change this line, remove this line from there and write it after Python developers salary. Okay, and now if I run it, you can see Python developer salary is now in blue and all developers are in orange. So yeah, Python developer salary is higher than the all developer salary in most of the case. So that's why it's actually overlapping. So you can't really understand like which one is for which one, right? So in that case, we just need to use something called indexing. Okay, indexing means it starts obviously with 0 and goes till the length of the particular list. So here we have 25 to 35, right? So you can obviously use to 0 to the length of the whatever that is. But that is one thing. One more thing, one short thing, we can use, that is NumPy. We can just create an array of the indexes using NumPy with a single line. Okay, you don't need to write it manually. So if you don't know NumPy, that's also fine. Just go to refinder.com. Let me just go into that quickly. And there just click on this courses. And here you can clearly see we have a NumPy module tutorial. It's all free and it's like I think approx 1 hour tutorial, and it's free to enroll. You can just enroll that course and learn about NumPy more. Okay, so you should install NumPy on your device by writing pip install NumPy, and we also need to use that thing, right? So we are just going to write import NumPy as np. Okay, that's it. And after writing, all edges, okay, yeah, after that we are just going to write indexes, x indexes or indexes underscore x for x axis only, right? So here we are just going to write np.arrange because we already shorted the NumPy as np. So np.arrange, it's really easy. It is not a rocket science. Okay, it's really easy. And yeah, np.arrange, then we have to just put the length of the all underscore edges x. Okay, that's it. And that means indexes will contain 0 to the length, length minus 1 numbers. Okay, so here the length is I guess 11. Yeah, 25 to 35 it's 11. So it starts from 0 and goes till 10. Okay, and now we just need to change this all edges x with the indexes. Okay, let's just copy this thing and paste it over here, and as well as paste it over here. Okay, fine. And since we are now using the indexes instead of the values, we can just do one more thing, that is we can just change the width of that particular plot. So by default it's 0.8, okay, 0.8. So you can clearly see the total amount of width is 1 and the bar is of 0.8. That's why it's creating a gap between two bars, right? So yeah, so now since we have all the controls to the bar, we can just change the width of these bars, right? So let's make one more variable for width and just make it 0.34, whatever you want. Since we have only two bars, two separate things for Python developers and all developers, so I can just write 0.35. Yeah, that's perfect. So if I use 0.35 for both the cases, so that means it will be like 0.35 for the first one, that is Python developer salaries. Then we have 0.35 for the second one, that is all developer salaries. Then it is going to, the total is 0.7, right? So it is going to make a gap of 0.3 between two bars, right? Yeah. So in this way you can use this width, or I can just make one more plot for JavaScript developer. In that case, we can just set it to 0.25. Okay, and let's do that. I'll just copy the all developer one and paste it again, and let's make it Java or JS dev y. Yeah, perfect. And this should be also JS, and let's change some values. If suppose it is 35,000 and now this is 38. Okay, so I changed the values of JavaScript developer average salary. So these are all assumptions, these are not true values. Okay, and yeah, let's do that. Let's change the width. So first of all, let's run this cell and let's see how it's working. Okay, there is an error. NumPy has no attribute called arrange. Okay, it's a single R, not double R. Perfect. Let's run it. Yeah, now you can see it's also still overlapping. That is because we are using indexes, but that's also the same. We didn't use the width. So we set the width to 0.25. So let's minus this 0.25 from the first one. So this will be 0.25, or I can just write the width. Yeah. And the second one will be perfect of indexes x, and the third one will also be last width. Okay. It's width. Yeah. Perfect. So let's run it. Well, you can clearly see it's still overriding the previous values, right? That is because we need to set one more attributes inside the bar method, that is width. So for example, after these y-axis values and before the labels, we can just write over here width is equals to width. Okay, so the first one is the attribute name and the second one is the variable which you created, that is width. You can, if you just create a WID, then you have to write over here WID. So this is the variable. Okay, and yeah, let's put a comma over here and let's just copy this thing from here and yeah, paste it over here as well as paste it over here. Perfect. So now if I run it, you can now clearly see that we can really understand these things. Okay, so let's change it with JS developers. JS, yeah, perfect. So you can see the yellow one is for JS developers, red one is for all developers, and blue one is for Python devs. And you can clearly see that for first one, let's zoom it a bit. Yeah, you can see that for the first one we have this Python developers bar, then we have the all developers bar, then we have JS developers bar, right? So now we can clearly understand this. So let's just change the styles, because it has this grid system, that's why it's really confusing for now. So let's choose something, Seaborn poster, copy that particular style and paste it over here. Okay, let's run this cell again. Now you can clearly see we have these separate things, right? Separate width for every particular plots. But there is one more problem. Let me just minimize the screen a bit. Yeah, you can clearly see there is one more problem. The x-axis labels are now changed, right? So now it's changed with indexes 0 to 10, isn't it? So that is because of we are using indexes as x levels. So we have to change that thing. So for that we have a method called xticks. Okay. So after writing the x label, or before writing this x label title and all, we can just use one more thing, that is plt.xticks. Okay, and inside the parenthesis we have to just write ticks is equals to indexes. Okay, it's not fixed, it's ticks. Okay, ticks is equals to the variable for indexes, that is this one. I'll just copy this thing and paste it over here, and then comma, then we have the labels, right? Labels will be equals to all ages. Copy this thing and paste it over here. So now if I run it, you can see now the x level is changed with the values 25 to 35, right? So in this way you can plot a bar graph. Okay. So guys, now let's see how to make a horizontal bar graph. So since we already saw that how to make a vertical bar graph, so yeah, let's make a horizontal bar graph. But this is not a appropriate data to make a horizontal bar graph. So we are going to actually use external data file to to plot this kind of graphs. So yeah, in kaggle.com we have this CSV file for marketing sample for naukri.com. So this is the naukri.com to find jobs in India basically, and these are the datas, like let me show you this data. Yeah, so you can see these are the data of like how many people are doing what kind of jobs and all. Okay, so yeah, we have this functional area, right? So in functional area we have this in a company, in a particular company there are vacancy of jobs like marketing, advertising, MBP. Okay, then the second company has this kind of vacancies and all. Okay, so yeah, we are going to plot a horizontal bar graph according to that particular data, right? So there are basically two ways to use a CSV file. The first one is obviously the import CSV using the CSV module, and there is the second one that is like using the pandas. Okay, pandas library. So we already have a course on free pandas library, Python pandas library, and the course is absolutely free. You can see over here. You can just enroll that. If you don't know about pandas, you can just enroll this course and learn about that. Okay, but now we are going to just use a CSV module. Okay. Later on we will see how to use the external CSV files using pandas. Okay, so yeah, let's import CSV. You should run pip install CSV before writing import CSV over here. Okay, and then we obviously need to get numpy, import numpy as np, and then we also need matplotlib. So from matplotlib import pyplot as plt. Okay, that's it. And now let's just choose a style, that is assume plt.style.use, and then the style can be 538. Okay, 530, I don't know the spelling, let me just go up. Yeah, let's copy this word from there, and yeah, and now we are going to import that particular CSV file. So we have this CSV file, that is, let me go into the folder. Yeah, we have this jobs at naukri.csv, right? So I'll just going to write with open, then we have let me just copy this from here, from my second screen, because it is already open in my second screen. Yeah, from with weapon the jobs at naukri.csv as CSV reader. Okay, that's it. Now let's just read the file. Okay, CSV file, actually it's file, CSV file. Okay, and now let's just read the data of that particular CSV file, right? So CSV underscore reader, and there are basically so many ways to read the data, like you can just write CSV dot reader. Okay, but we are going to use CSV dot dict reader. That is because in order dict or any kind of dict, it's really easy to understand that data and modify those data. Okay, so we are going to just use dict reader. Okay, and then we have inside the parenthesis we have to send that particular CSV file. So we already imported the CSV file as CSV file, right? So I'll just copy this variable name and paste it over here. That's it. Now let's just now let's just print the first row. So row is equals to next, and that is CSV reader. Okay, because now the row is the first row of that particular CSV file, right? And now just going to print the row. Now you can see this is the first row, and basically this is the ordered dictionary. That is because of we using this CSV file as a dict reader. Okay, reading that CSV file as a dict reader. So we have this unique ID column, then we have crawl, timestamp, then job title and all. You can also see that in Microsoft Excel. You can see we have this unique ID, crawl time, job title, job salary, job experience, key skills, role category and all. But we are going to just use functional area. Okay, in functional area, okay, let's minimize this thing. Yeah, in functional area we have different kinds of available jobs, right? So yeah, we just need to write over here functional. Okay, inside the quotation we have to write let me just copy this name from here, functional area. Okay, fine, and paste it and run it. You can see we have this 5 functional area in the first row. Okay, marketing, advertising, M1, PR and media planning, and these are separated with space, comma, space, right? So since we want it as a list, we are going to split it with that particular thing, that is space, comma and space. Okay, so dot split space, comma, space. Okay, that's it. Now if I run it, you can see now it is a list containing all the functional areas, that is marketing, advertising and all, right? And yeah, now it's working fine. But there is one more problem. Since this is a really huge data, when you are working with all the data, now we are working with a single line of data, right? So that's why it is working fine. But when you are working with all the data at once, it may throw an error. That is because like it doesn't have that much of power to go through all the data at once. So I'll show you that thing as well. So let me just comment these 2 lines actually. Yeah, now if I just write over here for row in CSV reader and then just print the rows, you can see it started printing the rows, right? So this is the first row order dict and it's ended with over here. Then we have a second order dict, then we have third order dict and so on. But after a certain time, let me show you that thing. Yeah, after a certain time, it is showing Unicode decode error. That means it is not able to encode that total CSV file. So we have to use that UTF-8 method to encode that total CSV file. So for that we are going to use one more module, that is IO. Okay, so import IO, that's it. And you can clearly see we have this error right now, but after using this IO we will not get any kind of error. So instead of opening the CSV file directly, we just need to write over here io.open. Okay, io.open. Then we have this file name, CSV file name. Then we just need to write over here why you are going to open this file as a writing method, reading method, appending method, whatever you are using. So since we just want to read that file, so we are just going to write over here R. Okay, R means read that file. Okay, and then we just need to write one more line, that one more word actually, that is encoding. Okay, encoding is equals to UTF-8. Okay, that's it. That means now the whole CSV file is encoded as UTF-8. Okay, so now that will not, it will not throw any kind of error, because now the file size is really small and it can easily function the total files. Okay, so let's run this cell again. Yeah, now you can see it ran through all the files, and if you go down till the end, now you can see there is no error, right? So yeah, it's working fine. So let's remove these two lines, and now we are just going to yeah, there is one more thing. We have to actually count how many times these are repeating. Okay, so let's go into the CSV file, and you can clearly see, let me just show you that thing. Yeah, you can clearly see IT software application programming is repeating a lot of time. Here it is, here it is, here it is. Okay, similarly marketing is repeating a lot of time. So we actually want to count how many times these are repeating. Okay, so in that way we will get to find like the most number of job availability in total India, right? So for that we have one module, that is collection. It's also available on my website, that is refider.com. Right now, I think right now it's not available, but it will be available within 2 days. Okay, it's already uploaded there, but yeah, it will be available within 2 days. That's also for free. Okay, now let me just show you the basic things of the collection module. These are open in my second window, and let me show you that thing. So you can see this is the collection module videos, and let's show you the counter. Okay, so this is the counter. See, you can see this is a list of numbers, and some numbers are repeating. Okay, so counter basically does like, it will count how many times a particular thing is repeating. Okay, and it will show you according to that. For example, inside this list, inside the A list, the 4 is repeating 5 times. So that's why it's showing 4 is repeating 5 times, 2 is repeating 4 times, 8 is repeating 4 times, and all, right? And there is one more method in counter, that is most common. Most common basically does like what are the numbers which are repeating the maximum number of times. Okay, so yeah, this will basically show you the most common repetitions. Okay, so let me just send back it to the second screen. Yeah, and now we are going to use that thing. Okay, so from collections import counter. Okay, and yeah, now let's make a variable called functional area counter. Okay, FA counter, and that will be counter. Okay, counter and then parenthesis. And now we actually need to go through all the rows of that particular CSV file, right? So for row in CSV reader, we actually need to update the counter. Okay, that means for example, in the first line we already saw that in the first line we have this marketing, advertising, MB, PR, and media planning. Okay, so assume when it read the first line, it set all these 5 values to the 1 because they are repeating 1 times only. Similarly, when it goes to the second line, assume there is marketing also. Okay, inside the second line there is also marketing. So now the marketing will be count as 2, and else everything will be count as 1 because the marketing is now repeated 2 times, right? So yeah, we are going to use that thing. So for row in csv.reader, we just need to write over here if a counter, that means now it is going to count how many times the elements are repeating in these functional areas, right? So if a counter dot update, and inside the parentheses we will just paste this particular line because these are same actually. So this does basically it will just print, it will just count the functional area column, and it will split the different areas so that it can make a list of all the areas. Okay, we already saw that. So yeah, now let's just print the counter, print fa counter. Well, yeah, now you can clearly see that maintenance is repeating 8121 times, then IT software application programming is repeating 7400 times, sales are repeating 4060 times, and all. It is showing basically all the available posts of all the companies in India, right? So we don't want that. We want only assume top 10 posts, okay? Because if you are going to plot a graph of all the posts, this will basically make a plot of really huge size. We just want to make a plot of assume top 10 posts, okay? So we can just write over here fa counter dot most common, and inside the parentheses we can just write over here 10, okay? And that will basically print only the first 10 popular posts, okay? And now if I run it, you can see it is now printing only the first 10 popular posts, okay? Maintenance is 8121 and the last one is customer service, that is 3182, okay? And yeah, let's it's working fine. And now we have to plot the graph, right? But before that, we also need to separate these things. Like we want to separate the job sector and available post to different lists, okay? So let's make two empty lists like job underscore sector, and this will be an empty list obviously, and then available posts, okay? And that will be also an empty list. And now we are going to use a for loop for count in fa count dot most common 10. I'll just copy it from here and paste it over here, and then we are just going to append the first value with job sector and the second value with available post. That is because of, you can clearly see that maintenance should be in the job sector list and 8121 should be in the available post list. Similarly for IT software, it should be in the job sector list and 7400 should be in the available posts list, right? So yeah, let's just append those things. So job underscore sector should be append with count 0, and then we have available post dot append count 1. Fine. So let's just print these two things and let's see whether it's working or not. Job sector comma available posts. Let's run it. Yeah, now you can see these are now two different lists. So the first one contains all the job sectors and the second one is containing all available posts in that particular sector, right? And now let's plot the graph. So this is the final step obviously. So let's plot the graph. plt.bar, and the x-axis should be the job sectors, so job underscore sector, and the y-axis should be available posts, okay? Fine. And we also need to add some title and labeling so that you can understand it properly. plt.title, let's just make it available jobs in India, and then we have plt.xlabel, and this should be job sectors, and then we have plt.ylabel, and that should be available posts, okay? That's fine. And now let's write plt.show, okay? And yeah, now you can see it's showing the plot, but since it is a vertical graph by default, you can't really understand these really big terms, because you can see these are really big terms in the CSV file, like marketing, advertising. Then this one is really big, IT software application programming. So that's why it's now overlapping. You can't really understand. So for big terms, you can just use a horizontal bar graph. So for that, you just need to write bar h, okay? That's it, bar h. And now if I run it, you can see now everything is fine. It's plotting the graph and everything is clear, but there is still one more problem, that is it is now in the reverse order, because the top one is the smallest one and the lowest one is the highest one. But normally we saw like the top one is the highest one and the below one is the lowest one, right? So for that we just need to do one thing, that is job sector dot reverse. We just actually reversing the total things, okay? So reverse, and similarly for available post dot reverse. Fine. And there is one more thing, you can see the labeling are wrong. These are the available post numbers and these are the job sectors, right? So we have to exchange these things as well. So this should be Y label and this should be X label. So let's run it. Now you can see it's perfect. So these are the job sectors, these are the available posts, and now it is showing in the decreasing order, right? So in this way you can plot a horizontal bar graph. Okay. So guys, now in this video let's talk about pie chart. Okay, so assume we have a data of 5 persons. Okay, so in that case we can also use pie chart instead of bars, because mainly when you have a data of more than 5 persons or 5 things, then you use this bar plots. Okay, but when you have less than 5 things, then you can also use pie charts. So let me show you how you can use that thing. So obviously we have to import Matplotlib, obviously. So import matplotlib.pyplot, or you can say from matplotlib import pyplot, both are same basically, and we have to import pyplot as plt. Okay, then we can just set some slices, because you can see let me just quickly search in Google about pie charts, and you can clearly see in pie chart we have different slices, right? You can clearly see over here. So this is the one slice, then this is the second one, this is the third one. So we have different slices. So I can just write over here, slices will be equals to, assume 50 or 40 comma 70 comma 80 or something like that, some random datas. Okay, and then we have some labels. You can clearly see in the pie chart we have this one is for house, this one is for stocks, this one I don't know, folk or whatever. So let's make some labels. So labels will be equals to this is 40, and then the next one is 70, then the last one is 80. Fine. And now let's create a pie chart, right? So plt.py. To create a pie chart, you have to write plt.py. Okay, and inside the parentheses, let's just pass slices for now, and I'll show you how you can pass these labels and all. Okay, so after writing this, we can also add some titles. So plt.title, and assume this is a pie chart of random values, or whatever you can write over here, and then plt.show. Okay, that's it. Now if I run it, you can see we have a pie chart now. Okay, so this is the title, that is pie chart of random values. Then we have different color for different values, and this is like in pie chart, if the values are double, then also the pie chart will look same, because you can clearly see if I make it 80, the double of 40 is 80, the double of 70 is 140, and then 160, right? Now you can clearly see the pie chart still looks same, right? And now let's pass these labels. So labels will be equals to labels. Okay, now if I run it, now you can see we have these labels. So this is for 70, this is for 40, this is for 80. And we can also add a border, because you can see the border is now none, there is no border actually, but we can create a border of whatever color you want. Okay, so for that you just need to write over here wedge prop. Okay, wedge props, and that will be equals to, and then you have to write a curly braces, and then inside that we have to just write edge color, because it will make a color at the edges, right, at the edges of the pie charts. So edge color can be anything you want. So for now I'll just choose a black color, and then if I run it, okay, there is an embedded syntax. Yeah, this should be a colon instead of equals to sign. So yeah, let's run it. Now you can see we have a black color border, right? And what else? Let's just create yeah, explode. So before that, let me just choose the data from this horizontal bar graph. So we have this job sector and available post. Let me just quickly show you that thing. So job sectors, so this is the job sectors basically, and the available post at that particular job sector are some values, some random numbers, not random numbers, this is the true values of available post on that particular section in India. So we will just choose the 5
data. Okay, so we'll just choose the 5 datas. So let's just create you can say, let's just create a variable. Let's just copy only 5 data from here and paste it inside the slices. Okay, perfect. And again I'll just write job sector, and let's just copy only the 5 data, 5 values, and paste it inside the labels. Okay, fine, let's run it. Okay, there is an error. Label must be length of x. Okay, I think, yeah, we choose 5 slices, so we have to write 5 labels only, because we choose actually 6 labels. So let's remove one and let's run it again. So now you can see we have a pie chart of top available posts in India, right? So let's assume this customer service has something extra, or we wanna showcase only the customer service from this particular pie chart. So for that we just need to use a explode. Okay, explode will be equals to, assume by default it's 0, that's why the gap is 0 right now. So for customer service, that means the first one we have to set some gap, so 0.1, and except that rest of the things is perfect, so we will set them 0 by default. So 0 comma 0 comma, yeah, 4 times. That's perfect. Now if I run it, okay, now you can see there is no change because we didn't pass it over here. So we have to just write over here explode. It will be equals to explode, and let's run it. Okay, there is an invalid syntax again. Okay, we have to write comma over here. Let's run it again. Now you can see there is a 1% gap. So 0.1 basically means it will put a 1% gap over here. So if you just write over here 0.5, that means it will put a 50% gap over there. So you can see now this gap is actually 50%, right? So let's just put it 1 again. And you can also make this particular pie plot in 3D. So in that case you can just write over here shadow will be true. Okay, now if I run it, basically this particular theme doesn't have this option, so we actually need to change the theme. Okay, so I'll just choose this one and paste it under the import pie plot. Okay, and let's run this cell again. So you can see now the theme is changed, and now you can clearly see the shadows over here. So now it looks more 3D, and there is yeah, so you can see the customer service starts over here at this position. And if you wanna rotate the initial angle, you can also use start angle. So you can see the customer service starts with this particular line like this. Okay, now if you wanna make 90-degree angle, then it will start from here. Okay, so let's just write over here start angle, and that will be, okay, start angle, and that will be 90. And let's run this cell again. Now you can see the customer service is starting from here, not from there. Okay, so in this way you can also change the starting angles. And there is one more thing, that is string formatting. So if you know string formatting, that's fine. If you don't know, that's also fine. You don't need to learn that for now. I'll show you how you can use that. For example, you can see in this image we have the percentage as well. For example, the house containing 69% of the plot, right? So in that case we just need to use auto PCT. Okay, and then we can, okay, let's just put enter from over here. And yeah, now we can use the string formatting. For example, we can use float, integers, whatever percentage there is. So basically this total plot will be 100%, and customer service will contain some percentage of that 100%, then iTest will contain some percentage, LPO will contain some percentage, and all, right? So basically we want assume 1 decimal point percentage. Okay, so in that case we can just write percent 1.1 if percent. So this will show you the, you know, assume 90.1%, 80.2%, it will count up to 1 decimal point. And then we also want to showcase this percentage symbol. So this will basically means it will show something like this. Okay, let me just clear this thing out, and yeah, it will basically show something like this. 80.9 or something like that, and it will showcase you like this. We also want how to edit this. Yeah, we also want this percentage symbol after the number, right? So for that we also need to write one more percentage over here. Okay, that's great. Now if I run it, okay, there is an invalid syntax. Yeah, again we mistake the comma over here. So let's run it again. Now you can see we have this percentage. So all are basically 20%. Why is that? Yeah, so you can see all values are same, so it is basically divided into equal parts. Let's change this with 33,000. This one will be 3,000 actually, and this will be 3,800, and it is 4,000. Okay, let's run it again. Now you can see it is showing up to 1 decimal point in the percentage number, right? And if you just write over here 1.2, it will show up to 2 decimal point. You can clearly see now it is showing up to 2 decimal point. And since we also want this percentage symbol over here, that's why we wrote 2% over there. So this is all about pie chart. So in this way you can use pie chart when you have a 5 or less than 5 data, because when you have a large amount of data, this will basically a maze of all the data. So in that case it's suggested that you will use this horizontal bar graph or vertical bar graph, whatever you want. Okay, so guys, now let's learn about scatter plot. Okay, so scatter plot means basically there will be some markers in different sections of a particular plot. Okay, so let's first of all import Matplotlib, and then we can just write some values for x and y axis. Okay, so assume x axis values are 1 to 9, whatever you want. So I'll come back after writing the x and y axis values. Okay,
6.5 hours later.
so guys, you can clearly see I wrote some x and y values randomly. Okay, now it's time to create the scatter plot, right? So plt.scatter. So to create a scatter plot, you just need to write plt.scatter, and then you can just pass the x and y values, so x comma y. And we also want a label. Okay, so label will be anything like scatter plot or whatever you want basically. And then let's just write over here plt dot x label, and that will be x axis. So I'll just write x, and then plt dot y label, and that will be y axis. So I'll just write y, and then we also need to show some title. So plt dot title, I'll just write over here what else, like random values, and then plt dot show. Okay, let's run it. Now you can see this is the title and this is the x and y axis values. Okay, basically since we are using this 538 theme, that's why it added this grid and all. So let's just reset this Jupyter notebook. Let's just restart, and then I'll just rerun this cell again. Okay, so let's rerun this cell. Now you can see this is the default form of that particular scatter plot, right? So you can see there are some random dots and random values and all. We actually want to change some color and change the size, but like we do in the other plot like normal plot or bar plot or pie chart, we can't use color term or size term over here. We have to use the short form of that, like s is for size. Okay, so now if I just write s is equals to 500, now the size of all dot will be 500. We already learned about marker, so I'll just use a marker as well. So marker will be assume star or something like that. Let's just run this cell. So now you can see the size of the markers is 500 and the markers are star, right? And we can also use some different colors. So for that we can just write over here color will be black. K is for black. So let's run it. Now you can see it all black. You can also set different color for different different stars, different different markers. So let's just use some different markers. For example 0 or point, this will be a small point. So let's run it. Now you can see these are looking good. So let's just change some color. Okay, we can actually change the color by, you know, by the density. For example, this will be like in a deeper color and this will be the lighter version of that particular color. So we can change some density percentage in a list. Okay, so I'll just write over here color will be equals to we have actually 9 values, so let's just write some random 9 values. Okay, then I'll come back. So I wrote some random color values, so let's use that particular variable over here. So it should be now colors, right? Okay, yeah, perfect. Now if I run it, it may throw an error. Yeah, it threw an error. That is because of we use this color term. I already told you that you have to use S for size, C for color, right? So we just need to write over here C, that will be colors. Now if I run it, now you can see we have different colors, right? You can set a bar of, I'll show you that thing later on. We can also change the, you know, the blurry effect of it. So you can just write over here alpha is equals to alpha means, you know, how blurry this should look. So 0.5 will be perfect. So you can see now these are some light version of that previous one, right? And we can also use cmap. Okay, so cmap, basically let's just go into the documentation. This is the Matplotlib official documentation. You can see we have different cmaps, green, blues, these are the color cmaps. Then we have some summer, hot, spring, autumn cmaps. You can just randomly use these things. You can just try it out with summer, then if you don't like that, you can just go to the autumn or spring or whatever you want. Okay, so I'll just use a cmap of greens. Okay, so you can see in the color option we have, where is that, you can see we have greens. So let's just use greens, and now the colors will be, now you can see the colors are random, right? So this is yellow, this is green, this is blue and all. But now after writing cmap is equals to greens, now all the colors will be green. Maybe the deeper version on the lighter version, but now all the color will be green. Okay, so now if I run it, okay, there is a invalid syntax. Again we missed a comma over here, so let's run it again. Now you can see all are now green, right? You can also set a bar right side of that particular plot so that the user can understand if the color is deep green, that means the values are high. If the color is light green, then the values are low. So for that you can just use one more thing, that is c bar, right? C bar will be equals to, this is a method actually, so plt dot color bar, and then we can just write, okay, this should be plt, perfect. And now c bar dot set underscore label. Basically you can also use some labeling over there. So assume we are going to use some green color, right? So we can just make it a happy bar or something like that. So if I run it now, you can see we have this bar over here. That means if the color is deep green, the number will be around 9 or 8 or 7, something like that. The happy percentage is really high, and if the color is light green, that means the person is sad. Okay, so you can use this kind of bar beside the plot. And you can also you can clearly see I used color list instead of a particular color. Similarly, you can also use a size list instead of a particular size. So right now all the size is 500. You can create a size list of some sizes containing like 9 values. Okay, since we are using 9 values, so you have to use 9 values, and then you can just pass that particular variable over here instead of 500. Okay, so I'll just quickly write some values over here, then I'll come back. Okay, so I wrote some random size values. Now let's just pass this variable over here. S is equals to now size. So if I run it now, now you can see these circles are in different sizes. So this is the bigger one, this is the smaller one. So in this way you can use this scatter plot. Okay, and there is one more thing. I already wrote this label scatter plot over here, but this is not showing over here. That is because of we didn't use the legend method. Okay, so plt.legend will actually make this thing visible. Okay, and now if I run it, now you can see this scatter plot is showing over here, right? So in this way you can create a scatter plot in Matplotlib. Okay, so guys, now let's talk about stack plots, right? So obviously, first of all, we have to import the pyplot from Matplotlib. Obviously, you can also use the from Matplotlib import pyplot as plt, and then let's just let me just now let's just create some variables. For example, days, and that will be assume 1 to 5. Okay, 1 2 3 4 5. Fine. And now we actually wanna plot a graph of how many hour you study, how many hour you eat something, or something like that. Okay, you understand that thing? So I'll just create a variable called study, and that will assume on the first day you studied for 4 hours, then on the second day you studied for 3 hours, and something like. I'll just quickly give some numbers. Okay, and then assume for eat purpose you gave on the first day 2 hours, then on the second day 1 hour, and then let's just make one more variable called exercise, and that will be 5 3 4 5 3. That's totally random numbers. And now let's just make a stack plot. So basically a stack plot looks like this. Okay, the stack plot basically looks like this. So let's just make one. So plt, to make a stack plot you just need to write plt dot stack plot. Okay, and the first parameter you pass under this parenthesis is the x-axis values. So over here the x-axis values are actually days, right? So 1 2 3 4 5 are the x-axis values. So I'm just passing days, and then we actually need to pass the variables by which this kind of plot will be made. Okay, so these parameters are study, eat, and exercise. So study, eat, and exercise. Okay, now if I let me just quickly write the title and show. So the title will be daily routine and plt dot show. Okay, and obviously you can also make a label for x and y axis like plt dot x label and plt dot y label. I'm not doing this thing. Okay, so let me just run this cell, and now you can see this thing is made, right? So the x-axis values are 1 to 5. That means these are the days 1 to 5, and these are the values like how many hour I did something. Okay, so the blue one, actually you can't understand like which one is blue, which one is orange, and which one is green. So let's make a label for that. So label will be labels. Yeah, labels will be perfect. Labels will be study. The first one is study, then the second one is actually eat, and then the third one will be exercise. Okay, let's run it. Okay, yeah, we actually didn't pass the labels over here, so it should be labels equals to labels. Okay, and then we also need to write over here plt dot legend. Perfect, let's run it. So now you can see we have this study, eat, and exercise thing over here. So study is blue, eat is orange, and exercise is the green one. So you can clearly see on the first day I studied for 4 hours, so that means it's 4. Then 4 to 6, that means it's 2 hours, so I actually ate for 2 hours, right? And then 6 to 11, right? 6 to 11 is 5. So that means we exercise for 5 hours. So that's how this thing works. And you can also change the colors and this kind of things. So let's just choose colors is equals to assume red, or you can pass any kind of hex codes. So I'll just pass some hex code. Okay, so I'll just choose this. And the second one can be some deep color or dark color. Let's just choose this one and let's paste it over here. And then for the third one, let's just choose some different color. For example, this color. Okay, let's just run this cell now. Yeah, we didn't pass it over here as well, so it should be colors is equals to colors. Now if I run it, now you can see the colors has now changed, though the study is something grayish color. So let's just change the study color as well, because it's not looking good. Let's just choose this pink and paste it over here. Now if I run it, now you can see this is now pink, then the it is violet, and exercise is something yellowish color. Okay, so in this way you can plot a stack plot, right? So guys, now in this video, let's see how to change the legend positions. For example, by default, it's in upper right corner, right? So you can clearly see, let's just copy this thing from here and paste it over here. So this will basically make a stack plot, and the legend is at top right corner, right? Now let's move this legend position at the upper left corner. Okay, so yeah, over here plt.legend, and in the parenthesis you just need to write over here LOC, and that will be equals to, then you can just put a quotation and then write upper left. That means it will move to the top left corner. Now if I run it, now you can see it moved to the top left corner. Similarly, you can just write over here bottom left, then it will, okay, there is an error. Yeah, it should be lower left, not bottom left. So you can just write lower left, and you can clearly see over here there are so many options like upper right, upper left, lower right. Similarly, right, center left, center right, lower center, upper center, and center. Okay, so let's just run it, and let's also copy this lower center as well. We will see that how it looks actually. So now you can see it's in the lower left, and now let's just paste that one, and this should be in the lower and center of that screen, right? And if you just write over here lower left or something like that, you can clearly see the plot is starting over here, but the legend is actually in the more left side of that particular starting point, right? So you can also use some manual options. For example, right now we are just writing some like predefined words like upper, lower, bottom, left, right, center, something like that. But you can also use some numbers to change the position. For example, if you want it like slightly right and slightly up at the lower left corner, so you can just write over here 0.5 to the right, and then 0.3 to the up. Okay, now if I run it, okay, there is an error. Well, yeah, that is because of these are integers, so we don't need to write this quotation over here. So let's just remove these quotations from there, and now if I run it, okay, positional argument follows keyword argument. Okay, that means we have to put a parenthesis. Okay, so that means legend, then inside the parenthesis you have to write LOC, and that should be equals to, then again a parenthesis, and then 0.5 comma 0.3, whatever number you actually want. Like the first one will move to the right and the second one will move to the up side. Okay, now if I run it, now you can see it moved to the 0.5 right and 0.3 up. Okay, so I'll just make it 0.05 and 0.03. okay, now if I run it, now you can see it looks good, right? Now it's inside the plot, and yeah, it's basically looks good. So if you just let's just do one thing, yeah, study dot reverse. Basically now this last one will be in the first position and the first one will be the last position. So let's do that as well. It dot reverse, and finally exercise dot reverse. Okay, so let's run it. Okay, here is not, it should be it, not here. Yeah, now you can see it looks good, right? In the bottom left corner, not actually totally bottom and totally left corner, it actually giving them some space from the bottom and the left corner. So this actually looks good. So in this way you can change the location of the labels in any type of graphs. Okay, so guys, now let's learn about histograms. Basically, when you have a large amount of data, for example, you have 100 columns or 100 datas. Okay, in that case, if you draw a bar plot, then also there will be a multiple, 100 different colors, and it is difficult to understand all the things separately, right? Similarly, you can't actually plot any of these graphs or these plots which we already learned, right? So in that case, this histograms comes in, and in histogram it is basically, it will combine a certain amount of data and it will just plot that particular data. Okay, so let me just show you that thing quickly. So obviously we have to import pyplot. So import matplotlib.pyplot as plt, and then we can just make a list of certain ages or certain data. Okay, so for example, I'll just choose a age between 18 to 30 or 35. Okay, I'll come back after writing all the ages. Okay, so yeah, I wrote all the ages. Now let's just make a histogram plot, right? So to create a histogram plot, you just need to write plt.hist. Okay, and then you can just pass the variable where you store all the data. So for example, now it's ages, and then we can just write beans. Okay, beans mean like how many data will combine with each other. Okay, so if I just write over here bean equals to 5, so that means first 5 data will combine at once, and it will show you a plot of first 5 data, then it will show you a plot of the second 5 datas. Okay, and it will continue till the end of that list. Okay, and then we can also write age color or something like that. We will do that later on. Okay, so let's just make a title. It should be histogram or something like that. Okay, and then we can just also write the x label and y label. So let's just do that quickly. X label is basically the ages, and then we can also write the y label. So basically you can just write for example total responses. Okay, that means like you can clearly see that 18 is one time, then 19 is one time, 20 is two times, then first 5 data means it will count 18 till 22, because 18, 19, 20, 21 and 22, that means total 5 numbers, and in between there are actually these numbers, so that means there are 6 numbers. So total responses is 6, then it will count 23 till 27, that means there are 4 datas. And yeah, let's just write plt.show now. Okay, now if I run it, so you can see it is showing that data, right? But there is one more thing, we can't actually separate all the 5 columns, like first 5 data and second 5 data is actually merged over here, because they are not have that different colors. You can obviously set different colors for everyone, but you can also write age color. Okay, age color can be anything. For example, I'll just choose black. You can write black or K. So let's just run it. Now you can see we have these separations over here, right? And since we have now a limited number of data, that's why it's really easy to understand all the things. But when you have a large amount of data, it will be a messy thing. So in that case, you can use logarithmic terms. Okay, so for example, this is 1, right? So 1 into 10 to the power 0, that will be basically 1 actually. So you can use logarithmic term for large amount of data. So for that, you can just write over here log will be true. Okay, now if I run it, now you can see these are in the logarithmic terms, right? And also you can write some medians, mean, those kind of things. Okay, so let's just assume we have a median 28 or something like that. Okay, so let's just write median is equals to 29, and then I can just write over here plt.axv line. So this is basically a vertical line for that median. Okay, so if that is 29, so it will basically count the median of that particular section. That means 29 is over here, 27.5, and in between 30 and 27.5 it should be over here, and it will create a vertical line over here. That means this is the median point. Okay, so yeah, so let's just pass over here median, that is the variable which I created, and then we can set some colors to that, so that it can separate the diagram, the plot actually. So color can be anything, some bright color will be better, so I'll just choose red, and then there is some labeling. You can just write some labels. So I can just write over there age, median. Oops. Yep, perfect. And then also yeah, that's it. Now if I run it, now you can see we have this median over here. You can also customize the width of this particular line by writing line width. So you can just write line width. So by default it's 1 actually. So if you just write 3, now it will be more thicker. Okay, so now if I run it, now you can see it is more thicker. And yeah, in this way you can plot a histogram when you have a large amount of data. Okay. So guys, now let's learn about how to fill the area between two line plots, or you can say, so let me just show you one thing. If I go up, you can see we have these line plots, right? So this is the 2 line plots, and sometimes it is there, like when you have to show the area under a particular value. For example, if you wanna show the area under this 50,000, that means this particular area should be filled so that the user can, or the customers can understand that this is that particular amount of data you require actually, or something like that. Okay. And when you have multiple line plots, sometimes you need to fill the area between 2 lines. That means this particular area should be filled. So in that case, this thing will really helpful. So I'll just quickly grab these lines of code so that I don't need to write it again. Okay, and then I'll just paste it over here and let's run it. Okay, so you can see it ran properly. So obviously you have to import that thing first. So since we are using Jupyter Notebook, I already imported that thing initially, so I don't need to import that again. So this is the ages of the developers, and this is the average salary of the developers at that particular age. Okay, so this is not the actual data, I just wrote it randomly. Okay, and yeah, now let's just make a median so that so that assume above that particular level the developer gets really quite a high salary, and under that particular level the developer gets quite low salary. Okay, so let's just write median is equals to assume 53,000. Okay, to create a area between 2 line plots, or any kind of line plots, you just need to write plt dot fill between. Okay, so fill underscore between, and in the parentheses you have to pass the data of x-axis. That means we have these ages, right? So dev x, that means this is all the ages, and then we have to pass the y-axis variable. So that means this is the y-axis variable, and then we have to pass the median. Okay, so median. So now if I run it, you can see now we have an area, right? And these 2 areas are separated at that position, that is 53,000, which is the median, right? So above above that particular median, the areas are actually in downside, and below that particular median the areas are actually in upside, right? And yeah, in this way you can create an area of a particular plot. So assume now we have 2 different line plot. Okay, so let me just quickly copy this one. This has 2 different line plots, so I'll just copy this one and paste it over here. Okay, now if I run it, now you can see these are actually all developer salaries are in blue color, and Python developer salaries are in orange color, right? And now I need to write these medians as well. I'll just quickly copy these 2 lines from here, and after plotting these 2 line plot, I'll just paste that line. Okay, so median and then fill between. Since now we have these 2 different plot, instead of writing over here median, we can just write over here Python underscore dev y. Yeah, perfect. And now we can just write a condition where the Python salary is greater than the all developer salaries. Okay, so I'll just quickly write that thing. This should be greater than the all developer salaries. Okay, and now we also need to write interpolate. Okay, interpolate is equals to true, and we can also change the densities, the the blurry effect of that by writing alpha. Let's not write that for now, and if I run it now, so you can see now it is showing some plots, okay, and some areas, okay, in between the lines. So let me just quickly how can I differentiate? uh, I'll just copy this again and paste it over here, and I'll remove these two lines. And now if I run it, now you can see, yeah, so you can clearly see this is the area in between the two lines, so that's why it is filled. Then again, this is the area in between two lines, so that's why it is filled. And again, this is the area in between two lines, so that's why it is filled. Okay. So guys, now in this video, let's see a time series data. Okay, so when you have a data of a dates, okay, for example, let me just show you quickly. So we have this total dates.csv. Okay, so this is a total date regarding coronavirus. Okay, so we have the total date of the world data. Also we have total dates of country wise of this month, that is July. Okay, July 2020. Let me just quickly open this in Microsoft Excel so that you can understand it better. Okay, so yeah, you can see we have these dates over here, and we have the world total dates. Also we have the country wise data. We actually don't need that for now. We will work with the world data. So yeah, we have these dates and we have these values, right? So in case if you wanna perform certain task on some which has dates, in that case this time series data plot will be really helpful for you. So let's just quickly import Matplotlib. So I mean pyplot. So from Matplotlib import pyplot as plt, and also we want to import dates from Matplotlib. So from Matplotlib import date, okay, dates actually, and maybe we will import that as dt. Okay, and now we also need pandas, but not for now. We will first see how to create a basic time series data plot. Okay, and then we will see how to perform certain tasks on that particular csv file, right? So yeah, so let's just quickly write some dates. So I have these values in my notepad, so I'll just quickly grab this thing from here and paste it over here. Okay, so this will maybe, yeah, these are the problem in Jupyter notebook, so I manually need to put a tab over here. So yeah, we have these dates now, right? And let's create a y-axis values. So yeah, y-axis values can be like anything. So I'll just quickly write 0 to 9 values. So 0 comma 1 comma, I'll come back after writing all this. So you can clearly see I wrote the dates as well as the y-axis value. So yeah, now let's just plot the time series data plot, right? So to create this time series data plot, you have to write plt dot plot date. Okay, so plt dot plot underscore date, and inside the parentheses we obviously need to pass the dates. So dates comma y. Okay, so x-axis values and the y-axis values. Okay, and obviously we can set any line style or marker. So by default it's, I guess, a dot marker equals to dot. So yeah, let's run it. Okay, there is an error, no module name mat well, I guess there is a spelling mistake. Yeah, now if I run it, so yeah, you can see the date time is not defined. That is because of we didn't import the date time module. So we also need to import the date time module. Okay, so import date time. Okay, and in case if you don't know this date time module, you can just quickly open my YouTube channel. I have a YouTube channel, so I already uploaded this thing like 7 hours ago. So the date time module, it is a 28 minutes long video, so you will get all the basic things about the date time module with some some external files. Okay, and yeah, so now let's run this cell. So you can see this plot is now created, and by default the marker is actually dot, and you can clearly see that the dates are actually overriding, right? So let's just use some some styles. So plt dot style dot use, and then we can also use a seaborn style, so that will automatically make this plot a little bit bigger, and as well as it will create those grids so that you can understand properly. So let's just write over here seaborn. Okay, and now if I run it, so you can see now we have this plot. Still the plot is really small and the dates are still overriding, right? So we can also resize the plot by writing some methods. So plt.rc per params, and then we need to write a box bracket and then quotation. Then inside the quotation we have to write figure dot fig size. Okay, now you can write any size over here. So I'll just put 20 comma 20. Okay, now if I run it, so you can see now it looks bigger, and now it is containing the whole width of the screen, and the dates are now looking good, right? You can understand the dates properly, and you can clearly see the dates are actually in the points are actually marker equals to dot. You can obviously change that thing, or you can also remove that thing by lighting marker equals to none. Okay, and you can also change the line styles. You can clearly see there is no line style, so you can just write over here line style is equals to solid. It will make a solid line. So now if I run it, so you can see it is a solid line, and obviously you can just write markers equals to none. Okay, it should be marker. Yeah, now if I run it, so now you can see there is no marker over here. I'll just put it by default, the default one, that is the dot one. Okay, and now if I run it, yeah, now you can see this is the default one. And yeah, you can also change these styles over here, or the string formatting, in case if you yeah, I already told you that if you want to learn more about this DIptam module, you can quickly go into my YouTube channel, and from there you can just learn that thing. Okay, and yeah, so let's just quickly change the style of these dates. Okay, so let's just make it some some curvy or some reclined style. So to change the figure of the dates, you just need to write plt.gcf. Okay, and then a parenthesis because this is a method, and then dot, then auto fmt underscore x date. Okay, and then put a parenthesis again because this is also a method. So now if I run it, you can see there is no error, and now you can see this is now a reclined lateral format. Okay, so this is now looking good, and also you can clearly see this is a format like default format, that is year hyphen month then hyphen at the date. Okay, you can obviously change the string format as well by using strf time or strp time. Okay, you can just quickly go into the DIptam module and learn about that. So yeah, so let's use that thing as well, right? So for example, I want to change it with the month, then the date, and then the year. Okay, so for that I just need to write over here. So let's just make a variable date date underscore formatter. Okay, and that will be equals to, we actually make it the matplotlib dates short form is dt. So I'll just quickly copy that thing from here and paste it over here. Then we just need to write over here date formatter. Okay, so that means now we can change the formats. So let's just quickly write over here the month. So that means percentage b, then percentage small d, and then I'll just put a comma. Then we want the year, so percentage capital Y. So capital B means it will write the total month name, that means June means JUNE, July means JULY. But if you write small letter b or lowercase b, that means it will only write the first three character of every month. That means June will be equals to JUN, July will be equals to JUL. Okay, and similarly if you write capital Y, that means it will write the total year 2020. Okay, but if you write small y, it will write only the last two digits, that means only 20. Okay, and yeah, but now we actually change the format inside this variable. Now we have to use that variable as x-axis, right? So we want to change the x-axis format. So for that we also have this gca, we have this gcf method to change the figure. We have this gca method to change the axis. So plt.gca, and then the obviously parenthesis because this is a method, and then x-axis dot set underscore measure underscore formatter. This is a really long method, and inside this parenthesis we have to pass that variable as an argument. So let's just quickly copy this variable from there and paste it over here. Okay, now we also need to write plt.show to show the plot. So now if I run it, okay, So you can clearly see now the date format is actually changed. Let me just quickly zoom it a bit. So you can see the date format is changed. Now it is a month, then the date, and then a comma, then the year, which we choose over here. Month, then date, then comma, then the year. Okay. So yeah, in this way you can quickly make a time series plot. Now let's see how to use the external file data. So we have this data over here which has this 11, actually the 10 datas or 10 rows which contains dates and worldwide death regarding coronavirus, right? So to import that CSV file, we also have the CSV module, but for now I'll just use the pandas. So if you don't know pandas again, you can just quickly open my Definer website, definer.com. Click on this courses option. It will open this kind of page, and we have this Python pandas library tutorial, which is 1 hour 12 minutes long. And from there, you can obviously learn that Python pandas module. Okay. So let's just import that thing. So import pandas as pd. Okay, now I'll just quickly, okay, let's do one thing. I'll just make a new cell for that. Okay, so I'll do it over here. So now we have these pandas over here, and I'll also copy these two lines from there, so that we also get the stylings and the resizing methods. So yeah, now let's just quickly open that particular CSV file, right? So I'll just make a variable called data that will be equals to pd.read_csv. Okay, and now inside the parentheses we have to pass the data, I mean the the file name. So the file name is actually total_dates.csv. You have to write total things, so total_dates .csv. Okay, and now we have this date column and this world column, right? So let's just quickly make a variable called month_date. Okay, and that will be containing the data, and then the box bracket we have this column name that is date, right? So let's just check it again. So yeah, we have this column name called date. So now this month date will contain all the dates from that particular column, right? And also we need the world underscore data, and that will be containing the data. In the box bracket we have this world column, right? So w is in capital, so let's just write that thing, world. Okay, now yeah, we have the date column inside the month date variable, and we have the world date numbers inside the world data variable. Okay, now let's just quickly make this plot. So I'll just quickly copy the line from here. Yeah, I'll just quickly copy these two lines from there and paste it over here. Now let's just change the variable names only. So this date should be month date, and world data will replace y. Okay, now if I run it, yeah, you can see we have these dates over here. So 7/1/2020, then 7/2 till 7/10. That means the total first 10 dates of July. Okay, and we have the total date graph over here. So in the first day of July, the date was around 510k, and on the 10th day of July, the date was around, I guess, 57k. So let's just quickly check that out. Yeah, you can see on the first day it is actually 511k, and on the 10th July we have these 554k dates, right? So in this way you can make a time series plot. Okay. So guys, now let's talk about subplots. Okay, so when you have multiple plots inside a same plot, in that case it's better to use subplots to separate both the things. Okay, so yeah, you can see we have these all developer salaries as well as Python dev salaries, right? And these are all assumptions, these are not true values. Again, I'm saying that. Yeah, so we actually plotting that thing. So yeah, so all developer salaries plot is actually in blue color, and Python dev salaries are in orange color, right? So if I run this cell, it will plot this kind of thing. And to use subplot, first of all, we obviously need to learn the basic things. So yeah, so to create a subplot, you just need to write over here fig. It should be fig. You can write anything over here. It is a variable name, obviously, so there is no it is not case sensitive. You can just write anything, and let's just make ax, okay, and that will be equals to plt dot subplots, okay. And now that means instead of writing plt everywhere, we can just write ax, okay. So quickly that copy the ax and paste it over here, as well as paste it all the places where the plt is present. But there is one more thing. When we wrote plt, we can just write plt dot title, right? Similarly, we can write plt dot x level, but I don't know why they just changed that thing. So when you write the subplot variable name, that is ax or whatever you wrote over there, so in that case you just need to write set title, set x label, set y label, okay. So set underscore titles, and similarly over here set underscore x label and set underscore y label, okay. Now if I run it, you can see there is no error. It ran the code and it is showing the similar which we already saw when we ran through the previous code. So why we are doing this kind of things? That is because of it is not useful when you are making these two plots in a single plot, okay. So when you want to separate these two things, in that case it's going to be really helpful. So let me just quickly show you how it works. So let's just go into the next cell and let me just quickly show you how it works, okay. So phi comma ax is equals to plt dot subplots, right? And we are actually using this thing for now. So now if I just print the ax, you can see it is a basic plot, right? But there is something like rows and columns, okay. So if you just make it in rows equals to 2 and in cols equals to 1, now if I run this code, now you can see we have 2 rows, 1 column, right? So these are the 2 rows and 1 column. So this is really helpful when you are plotting. Assume this one, okay. So for in the first plot, we can just plot the all developer salary graph, and for the second one we can just plot the Python dev salary, right? Similarly, when you write in cols equals to 2, that means number of columns is 2 and number of rows is still 2. So if I run it now, so you can see we have this kind of plots. So 2 rows, 2 columns, okay. So this is the main thing of subplots. You can make any number of rows, any number of plots by dividing a single plot, okay. So we have this single plot and now we can divide it into any number of parts, okay. So since we have only two data over there, all developer salaries and Python developer salaries, so we can just use that one, okay. N rows is equals to 2 and n cols is equals to 1. So we can just make this kind of plots and we can separate the both the salaries inside both the plots, right? So let's do that. So yeah, we have to just write over here n rows equals to 2 and n cols equals to 1, okay. And since now we have these 2 rows, we actually need 2 variables. For example, we have only ax right over here, right? And we also need one more variable to store the second row, right? So let's just put a parenthesis over here and make it ax1 and ax2, okay. So ax1 means this particular above figure, okay, and ax2 means this particular plot, okay. So yeah, let's just use those things. So instead of writing ax normally, we can write ax1 for all developer salaries and ax2 for Python dev salaries, okay. And similarly, we have these title labels and y labels. So we also need to copy this thing from here and paste it under the ax1. So this should be ax1 title, ax1 x label, ax1 y label, and this should be ax2 title, 2 label and 2 y label. So now if I run it, so you can see, let's just remove this cell for now, okay. So you can see we have these 2 plots divided by a single plot. So this was a single plot previously, now it is divided into 2 plots, and you can see we have this title 2 times, which is really odd. So we can just quickly remove this title from the second one. So we only want the first one's title. So now if I run it, now it's quite good, and there is, I guess, yeah, So we can clearly see that the x-axis values are also repeating. We also don't want that. We want our x-axis values as the bottom of the total plot right over here, not over there, right? So we can basically share these x-axis values. So by writing share x, okay, you can also share the y-axis values also by writing share y. So share x can be true. Okay, now if I run it, so now you can see we have only these x-axis values, not over here. But there is one more problem. We have this legend only for the Python devs, not for the all devs. That's because of we only wrote over here plt.legend. So let's just quickly remove that also, and let's just make it ax2.legend and ax1.legend. Okay, now if I run it, so you can see both the things have this legend thing, right? So by writing in this method, we already have that single plot, single big plot, and now we are dividing that big plot into two smaller plots. But what if you want two big plot by dividing one single big plot? Okay, in that case you can just separate this ax1 and ax2 these things. Okay, so I'll just quickly comment this thing and write over here again fig. Since we are making two big plots, so we also need to change the figures for both the things. So it should be figure 1 and ax1. Okay, and that will be equals to plt dot subplots. Okay, and the next one can be fig 2, that means figure 2 and ax2. Okay, and again it can be plt dot subplots. Right, now if I run it, so now you can see these two are now separated into two big plots. So both the things are totally separate, they are not related to each other, and yeah, in this way you can use these subplots. Okay, so guys, welcome to the fourth session, and this is the last session. And in this session we will learn about how to plot live graph, as well as we will see how to plot three-dimensional graphs. Okay, for example, we already learned how to draw line plots, scatter plots, bar plots, and now we will see how to draw them in three dimensions. Okay, so in this video we will just see how to plot a live graph, and basically for that you can't really use this Matplotlib. Yeah, there are some ways you can use live plots in Matplotlib, but I'll suggest you use any kind of ideally except Matplotlib, except the Jupyter Notebook and Spider. Okay, so we will use this VS Code. You can see Visual Studio Code, and we are inside that particular folder. Okay, and we have this example .txt. Let me just open that thing, example.txt. Yeah, so you can see we have these things. Okay, so 1 2 3 4, these are like the x-axis values, and then we have the y-axis values. Okay, so let's just quickly create a Python file, right? So live plot.py. So obviously we need Matplotlib, so we are going to write over here from, import matplotlib dot pyplot as plt. Okay, and then we also need animations. Okay, so import matplot it should be matplotlib dot animation as animation. Okay, and now let's just use some kind of stylings so that it looks good, right? So plt dot style dot use, and then inside the parentheses we have to write 538, which is basically my favorite one, 538. And now let's just make a figure and the axis. We already learned the figure and axis inside in the subplot tutorial, so yeah, we are going to use that thing. So fig will be equals to plt dot figure. Okay, and then we need the axis, so ax or anything you can write over that, ax1, ax2, anything. So yeah, it should be fig dot at underscore subplot. Yeah, and it should be 1 comma 1 comma 1. Okay, fine. And yeah, now we need that the example1.txt inside this Python file, right? we can actually make a function which will open this file whenever we need them, right? So yeah, def animate, or you can write anything over there, right? And it should be I over here. I actually is an argument. So yeah, inside the animate function we obviously need to open that example.txt. so I'll just make a variable called data, and that will be equals to open, and then inside the parentheses we need to write that particular file name, that is example.txt, and then we need to write over here why you are going to import or use this file as a read, write, or whatever. So actually we need to read that particular text file. We don't need to modify anything. We don't need to write anything over there. So I'll just write over here r, okay, and then we also need to write over here dot read. Fine. And you can see that inside this file we have the first data, then in the next line we have the second data. So we obviously need to use lines over here. That means every particular line is divided by the next line. So it should be data dot split, and then it should be the new line quotation like \n, and now lines will contains all the lines. And now we actually need to separate the x-axis values and y-axis values. The first one is the x-axis values and the second one is the y-axis values, right? So yeah, I'll just make a list. X values equals to a list and y values equals to a list, okay. And then we need to use for loop so that it can iterate every time how long this file is. So for line in lines, we actually first of all need to separate these two things, right? So x this is the total line, so we actually need to separate it by comma, right? So yeah, let's just write over here x comma y is equals to line dot split, and then it should be comma and space. You can clearly see over here we have this comma then a space. Okay, I think there is no space actually, so I'll just remove this space from here. And now we need to append the x and y with the x values and y values list. So x underscore values dot append, it should be x over there, and y underscore values dot append, it should be y over here, right? And now we have the x-axis and y-axis value. Now let's just plot the diagram, live plot, right? So yeah, so let's just use that thing. So yeah, inside the function we actually need to write over here ax dot plot, and the x-axis values is x values and the y-axis values are y values, right? And yeah, that's it. Now let's just quickly use the animation so that it can actually, it is not an animation, it is a loop which will run after a certain time, okay. So if there is any change in between that time, it will just change that thing inside the plot, okay. So yeah, we'll just write over here any is equals to create that live plot. We just need to use this function that is we imported over here as animation. So yeah, animation dot, it has a thing that is function animation, you can clearly see over here. So let's just use that thing, and now we need to pass the figure. So fig is the figure we have, then we have to pass the function where the where the iteration is happening. So it is animate, right? And now we actually need to write the interval which will pass as an argument in the animate function. You can see we have this I over here. So yeah, let's just write over here interval is equals to 1000 millisecond. It is actually in milliseconds, so if you wanna make it an interval of minutes, so you have to calculate according to that, okay. So yeah, now let's just use plt.show. You can obviously also use the plt.title, x label and y labels. I'm not going to use that thing for now so that the video should not be that long, okay. So now I saved that file. Now let's run it. So yeah, you can see we have these x and y axis values, right? So let's just open that particular file example1.txt, and you can clearly see the color is also changing after 1 second, right? So that is because of it is actually checking whether there is any change in the file or not. And you can see in the one we have this 10 values. So yeah, in the one we have this 10 values, then 2 is 4, you can see 4, then 8, then 9, 11, and continuing, right? So now let's just change the file. So 11 comma, let's just write 8. Okay, so it should be at a new value in the x-axis. Like after 10 it should be 11, and it will plot like in this point, like because there is this 8 over here, so it will the graph will decrease till this point. Okay, so now if I save this example1.txt, you can see it drew live, right? There is no time delay, nothing happens, and it is a live plot. Similarly, if I just change few more times, so for example 12 comma 50, now I'm using some bigger values, and oops, and then 13 comma 8. Okay, and now if I save it, so yeah, you can see in the 12 we have this 50 value, and in the 13 we have this 8 value again, right? So yeah, in this way you can plot a live graph. Okay, so now let's see how to plot a three-dimensional graph. Okay, so I'll just quickly make one more file that could be like 3dplot.py. Okay, and yeah, that's it. Now let's just use that thing. So obviously we need to import the pie plot, so I'll just quickly copy it from here and paste it over there. And now we also need something that is mplot3d. Okay, it is by default in the Matplotlib. You don't need any external libraries or external modules. So yeah, from mpl underscore toolkits dot mplot3d. Okay, import axis 3d, this one. Okay, and now obviously we also need the figure and axes. So yeah, figure should be plt dot figure. Oops, yeah, figure, and the axis should be fig dot add subplot, and inside the parentheses you have to write 111, and then projection should be 3d. This is how the Python will know now you are going to plot a three-dimensional graphs. Okay, so projection equals to 3d. Okay, now like we do in the other plots, for example, let me just quickly open this Jupyter notebook. You can see, let me just go up. Yeah, so we have the x-axis values and y-axis values when we drew any kind of two-dimensional plots, right? But for three-dimensional we need x-axis values, y-axis values, as well as z-axis values. So over on two-dimensional array, the y-axis values are like this height over there, right? But for three-dimensional array, the z-axis values are actually the height of that particular plot, right? So I'll just quickly write some x-axis values and y-axis value, then I'll come back. Okay, I wrote the x-axis, y-axis, and z-axis values. Now let's just plot that particular three-dimensional plot, right? So plt, okay, we don't need to use plt because we are using this ax, so yeah, it should be ax dot plot, and now we have to pass the x-axis values, then y-axis values, and then z-axis values. And again, you can also use some other attributes like color, marker, size, and all line styles and all those kind of things. Okay, and now let's just quickly set some title and x label and y labels. So ax dot set underscore title should be like three-dimensional. Oops, it should be 3D plot, and now we need to write ax dot set, ax dot set underscore x label, and it should be x axis. Okay, and ax dot set underscore y label should be y axis. Okay, and ax dot set underscore z label, not order, it should be a z axis. Okay, now let's just write plt dot show. Now if I run it, So yeah, you can see now it drew this kind of three-dimensional plot, right? It has this x-axis values that is we wrote over there, and then y-axis over there, and the height is basically the z-axis, right? And you can also see it in any direction. You can clearly see over here. So this is basically a line plot, right? So now let's just see how to draw some scatter plots in three-dimensional. For that, you don't need to write anything over there. Just change this plot with scatter. Okay, that's it. So let's just close this one and let's run it again. So yeah, now you can see this is the scatter plot of the same values. Basically, you can obviously change the values, and you can see the you know, the nearby one has the higher alpha values, and the, you know, the far one has the lowest alpha values. So if you change it, the, you know, the densities of the color is also changed. So in this way you can plot a scatter plot. And now let's see how to plot a bar plot in three-dimensional. That is kind of tricky. So yeah, let's do that. Okay, so I'll just quickly comment these three lines. So for a bar plot, we need the x-axis, y-axis, z-axis values, as well as we also need the dx, dy and dz values. So yeah, we will use the numpy so that we don't need to write these 10 values again, right? So we are going to quickly import numpy as np. In case if you don't know numpy, you will obviously just go into my website, that is refiner.com, and from there you will see this kind of, okay, let's just quickly go back. You can clearly see we have this courses option over there, and just go into that courses option, and from there you will see this Python numpy module, which is actually around 1 hour long video. So yeah, you can just quickly learn numpy from there. Okay, yeah, you can see we have all the things inside this course list, course topics. So yeah, we will use this numpy for now. So let's just write dx equals to, then we need dy equals to, then we need dz equals to. Okay, so for dx and dy we actually want constant value, like 1 for 10 times. Similarly for y, we also need a constant value, that is 1 for 10 times maybe. So for that we just need to write np dot once, and in the parentheses we need to write 10. So it will basically make array of 10 ones. Okay, so yeah, now let's just write the same thing for y-axis, dy. So np dot once, in the parentheses we need to write 10, right? And for the dz we actually pass some values. Okay, so I'll just write some random values for for these 10 numbers. So I'll just quickly write those things. Okay, so yeah, I wrote some random values inside the dj list. So let's plot the three-dimensional bar graph, right? So yeah, we will use the ax dot bar 3d. Okay, now we have to pass the x-axis values, y-axis values, z-axis values. Now we also need to pass dx, dy, dz, and obviously we can also pass some colors, some line styles and all. So yeah, let's just not change anything more, and let's run it. So you can see now the three-dimensional bar plot is ready, but maybe for some values the the z-axis values are quite higher. You can see some is 6, some is 7, some are even 9, right? So that's why some plots are giving out some spaces over here. So yeah, that is because of z-axis values are starting from this 9 position, or you can say 7 position. That's why actually it is giving some height. So if you just change it with a constant one, so for example np dot once, and similarly for 10, and now if I close this one and rerun this code again, so maybe now it will look perfect. So you can see all are now starting from the this 1 position, right? So yeah, if you write constant z-axis values, that will be much better, because now it's quite looks good, right? So this is all about this three-dimensional plot. You can obviously plot any plots in three-dimensional using this access 3d module, right? So yeah, that's it for this video. Okay.